It's October the 3rd, 2011, and I've been working on the Wavetek 2407 signal generator to see if we could clean up the local oscillator. And we did. Found a solder splash on the back of the local oscillator board, and that seemed to be causing the little ringing or distortion in the local oscillator output wave. And now we have adjusted the oscillator, adjusted the crystal, and I have it comparing to the Rubidium standard. And let me get this light here. Well, that didn't fix it. So here we have two traces. The lower trace is the Rubidium oscillator, and the upper trace is the 2407. And you can see the 2407 just drifting slightly to the right, which indicates it is slower. And it looks like it's about a half cycle slower now than the Rubidium reference oscillator. I've been watching this for a few minutes, and it's drifting back and forth between fast and slow. This is the counter, the Heathkit counter on the, it's counting the Rubidium standard, and you can see it's about it indicates 3 cycles or 2 cycles low. Try to get a more accurate reading here in a minute. This is a local oscillator board, and I've covered the board. It's on the extension cable. We have the extension cables coming out, and the local oscillator board has been removed from its housing. This is the housing, the deviation meter, and modulator input section is in this middle housing. It's the other circuit board in the housing. There are 2 circuit boards in this housing. We left one in there. It's on the extension cable too. You can see the extension cable plugs in on the back there. And this is this is the local oscillator board. I'm going to uncover it. I've got this foam on it to try to keep it warm, to simulate the conditions in that aluminum box. This is conductive foam, so I put a piece of paper in between to insulate the board from that conductive foam. This is a local oscillator board, and this is a crystal oscillator. I put a little tape. I put a piece of tape over the hole of the adjustment hole. So let me swing back to the oscilloscope here. And you can see that they are really close in frequency. The 2407 is less than a quarter of a cycle low in frequency. At this point, there it's, oh, we can't even measure this anymore, it's so close. So here's our Heathkit counter. You notice quite a bit of error here. It indicates 9.8 99995.8 megahertz. So it's about it reads about 4.2. It's low in frequency. And so we've got the Heathkit counter within 4 cycles. I'm not sure we could do much better than that with that oven. Without an oven in the reference in the Heathkit. You see this is a temperature indicator, and I taped the sensor to the back of the Heathkit, and the surface temperature near the crystal is 93.7 degrees, and the other sensor is just hanging loose here on this wire, picking up radiant heat from the oscilloscope. So that's what's been happening here at the radio station, WA6RZW, in Elizabeth, Colorado this afternoon. Let's take one last look and see how we're doing on that. So we notice that the frequency is now drifting to the high side. It's picked up about a cycle. And that's since I lifted the paper off and the insulation off of the board. If I put that insulation back on there, the oscillator will settle down again. Thanks for watching the experimentation here.